Problem number 20. A car is driving against the wind at a constant speed v0 relative to the ground. The wind direction is always opposite to the car's velocity, but its speed fluctuates about an average speed of v relative to the ground. The air drag force is AV relative square, where A is constant and V relative is the relative speed between the car and the wind. What is the average rate P of energy dissipation due to the air resistance? Solution for problem number 20. Let's define U as V0 plus V. Here V0 is constant and V fluctuates. Then a relative speed of the car and wind is U plus delta U, where delta U average to 0. The instantaneous energy dissipation rate is force F multiplied by V0, and when we put expression for force, we finally have this expression. Here U square is constant, average for second member is 0, and the third member is always positive. It means that P greater than A V0 U square. And this is answer B, and that was solution for problem number 20. Problem number 21. A circular table has radius R and n greater than 2 equally spaced legs of length h attached to its perimeter. Suppose the table has a uniform mass density with a total mass m, and neglect the mass of the legs. Assuming the table does not slip, the minimum horizontal force needed to tip over the table is next one. Solution for problem number 21. Let's label the tops of two adjacent legs by B and C. The best way to push is to push directly opposite the table from the midpoint of BC directly towards this midpoint. When the table is about to tip over, these two legs will bear all of the weight of the table, and hence provide all of the frictional force. Balancing torques on the table about the axis BC, we have FH equal mgl, where L equal r cosine theta over 2 or r cosine pi over n is the distance from the center of the table to the midpoint of AB. Solving for F gives the answer F equal mgr over h cosine pi over n. Note that the credit was given for both choices B and C, since they are equivalent. That was a solution for problem number 21. Problem number 22. A collision occurs between two masses. In each internal reference frame, one can compute the change in total momentum, delta P, and the change in total kinetic energy, delta K, due to the collision. Which of the following is true? Solution for problem number 22. In a collision, momentum is conserved whether the collision is elastic or inelastic. This means that delta P equals 0 regardless of a reference frame, so delta P does not depend on frame. In an elastic collision, delta K equals 0, which is again independent of frame. In an inelastic collision, whatever kinetic energy is dissipated will go to heat up the masses, assuming they are isolated, and energy can only go into thermal energy. The heat capacity and the temperature change of the masses are both frame invariant, so the kinetic energy dissipated is again independent of a reference frame. This can also be shown more straightforwardly by direct calculation. That's answer A. Delta P and delta K do not depend on the frame, and that was solution for problem number 22.